All right, let's talk about section 8.4, which is data visualizations, different ways to visualize data, and talking about distributions of data and those kinds of things. All right, so distribution is just shows the observed or theoretical frequency of each possible data value. So it just shows you visually the data set that you have. All right, there's a couple different ways to represent data. There's lots of different ways, actually, but we're going to focus on two in this section. The first one is a histogram. And a histogram allows a visual interpretation of numerical data by indicating the number of data points that lie within a range of values. That range of values is called a class size or a bin, or bin size, all right? So this is what a histogram looks like, and we will generate histograms here in a second, but for right now, you just need to think about, we're just going to look at them and kind of analyze them. So we have, we can have distributions that are symmetric, okay? So symmetric distributions, when you sketch a curve over top of the histogram, you get like a bell curve, all right? A negatively skewed distribution means that you have more data points to the left of the median, okay? Remember, the median is the middle point. If you line up all the data points and pick the middle one, that's the median. If you have more data points to the pulling further away from the median, you would say, then it pulls the mean to the left, and it makes the data look skewed in one direction, to the left, or skewed negatively. If the same thing happens to the right, then you have the mean pulled to the right of the median, and we say it's skewed positively in the positive direction. It's the direction of the tail. If the tail goes left, it's negatively skewed. If the tail goes right, it's positively skewed. Okay, and I don't think we need to go through anything else about histograms. So that's the skewedness of histograms. And we'll talk more again about building them and why the bars are as tall as they are and that kind of thing. Let's skip to box and whisker plots, or sometimes they're just called box plots. Box plots are another way to visualize data. So you can take the same data set, you can make a histogram, you could make a box and whisker plot or box plot, and neither one is better than the other one. It just depends on your data and what you're trying to show or understand. So here we can look at symmetric data that, by the way, in a box plot, the middle line is the median. Okay, so half the data is to the left of the median, half the data is to the right. If it's skewed negatively, you get sort of this behavior here where the lower bound, the lowest data point, is further away from the median than the upper bound is. Same thing with the positive skewed data, except in the other direction. Okay, so this is positively skewed to the right. All right. So in this, just to kind of set up a box plot for you here and explain the parts, as I already mentioned, this middle point here, this middle line is the median. This line right here divides the top half, or 50%. So remember, 50% of the data is from the median to the upper bound here, the greatest value, as long as it's not an outlier. 50% of the data is there. Okay, so halfway between the median and the upper bound is the quartile 3, the third quarter. Okay, 25% of the data lies from here to here, 25% lies from here to here, right? And going the other direction, quartile 1 is that line, and that's, again, a quarter of the data is here, and a quarter of the data is from here to here, all right? And this can be skewed in different directions, okay? So you can figure out the center, you can generate these in a couple ways. I'm going to show you how to do it with Desmos. You can do it through graphing calculator as well, using stat, calc, and putting the numbers in a list, like I'm sure you've done in your other math classes. When we describe the center and spread, center is the median and the mean, all right? And the spread can be anything from the range to the standard deviation, which we'll talk about later. But basically, when we're asked to describe this, if the data is symmetric, then we can use the mean and the standard deviation. Standard deviation just gives an idea of how spread out the data is, right? And again, we'll get more into standard deviation later on. But for right now, just think of standard deviation as a metric for how spread out the data is. If the data is skewed, then as you've already seen in some of these graphics up here, the mean gets pulled away from the middle of the data. And so it's better to describe the data, or it's a better representation to describe the data using what we call the 5-number summary. Okay, the 5-number summary is the minimum, the quartile 1, the median, quartile 3, and the maximum of the data set. Okay, so those 5 numbers give a little bit better indication of the spread and center of the data. Obviously, median is a measure of the center as well. Okay, so let me show you how to do actually build a histogram. So a histogram is, again, a way to visually represent the data. And then what we're going to do is build a histogram, and then we are going to talk about, we're going to describe the data, whether it's skewed or not. Okay, so what I'm going to do is I'm going to sort of look at my data here, and I'm going to see that all of the values are between 7 and I think 23 is the maximum. So our minimum is 7, 23 is our maximum. Okay, so that means that so basically in the problems you'll be able to pick your bin width, and sometimes on the quiz it might be given to you, but if you can pick the bin width, and we're only going from 7 to 23, we think maybe 5 would be a good bin width, because that will lead us with not too many bars, but enough that we can get an idea of the data. Again, I'll show you how to do this in a second. All right, so that's what I'm thinking ahead before I do this. Now in Desmos, what you're going to do is you're going to type in all the numbers in a line. You're going to call it L for list, and then you're going to put in all the numbers. Now I've already put in the numbers here just to save some time. And once you've done that, it should say L equals a 20-element list. Remember, you've got to use braces here, not the brackets or parentheses. And once you've typed all of that in, then if you want a histogram, you just have to type in histogram, and it will default to just picking the bin width as 1. So watch what happens when the bin width is 1. When the bin width is 1, see, that means that basically all of the data points that lie between 7 and 8 are going to be graphed there. So there's only one data point that lies between 7 and 8. So you can see this is at 1 here. Okay, so the height of that is 1. So there's one data point, it's 7. If you go to the next one, you've got from 10 to 11. There is one data point that is from 10 to 11. By the way, it's including the lower bound. So 7 is included here, 10 is included here, 11 is included in the next one, and so on. Okay, so if I go by ones, I get quite a long list of just very small rectangles. I'm going to set the bin width at 5, so I tap the bin width, and I'm going to change it to 5, but it just adds a comma. If I change it to 5, look what happens. So now my bin width is 5, and I get a little bit more concise histogram. Okay. One other thing you want to check is that the bin alignment is set to the left. All right, so you can see my first bin goes from 5 to 10, again, including 5, not including 10. And you see there's only one data point there, which makes sense. 7 is the only one that would fall in that range. The next one is from 10 to 15. From 10 to 15, it looks like there is, let's see, this goes 2, 4, 6 data points in there, okay? And then it goes from 15 to 20. And then the last one here is 20 to 25. And in that, there's 5 data points. And if you go check, that checks out. So there's 1, 2, 3, 4, 5 data points there, right? That are between 20, including 20, up to 25. Okay, so to sketch this out, you're just going to simply take from 5 to 10, 10 to 15, 15 to 20, and 20 to 25, and you're going to put in the respective bins. So from 5 to 10, and well, I guess we need a scale over here on the left. So I'm not sure why I didn't just provide you with a graph here, but anyway, so we've got, let's go 2, 4, 6, 8, and 10, just to give us some space. All right, so from 5 to 10, there's just 1. So the height of that bar is just going to be 1. Again, just following the graph here. So then from 10 to 15, the height is 6. So we go up 2, 4, 6, and we'll sketch in a bar there. 15 to 20, it goes up to 8. Whoops. From 20 to 25, it goes up to 5. Okay, and so that's your histogram. That's it. Okay, and so once we've done that, we're going to describe the shape. This is a little bit difficult to see. It looks like maybe it's skewed left a little bit. You can also play around with the bin size, so you can change that bin size to 4. Sometimes that gives you a little bit better picture, or maybe even 3 would be better. And you can see when we go to bin size of 3, we can see pretty clearly that it is skewed to the left. So you can play around with it and to give yourself a better picture of its skewedness. So this is skewed left. Since it's skewed left, we would use, because it's skewed, we would use the 5-number summary to determine or to explain the shape or describe the shape. Now, the 5-number summary isn't generated here automatically from the histogram, but it does come from the box plot. So if we want to graph a box plot, all we're going to do is type box plot, and we'll put in L. This is easier on a computer than a phone, but anyway, we'll put an L right there, and I'm just going to turn off the histogram to avoid confusion, and you can see right here we get our box plot. Okay, and so we can figure out, I think on the computer you can trace, but I guess we'll just sort of look at the graph here. So our lower bound is, or our min, I guess I should say, so our min is 7, our Q1 value is 10, 11, 12, 13, so 13, the median, again that's the middle number, that's 17, Q3 is, looks like 19.5, and our max is, if we go to the right here, 23. And again, that would be, I think you can trace that on the, if you've got decimals on the computer. All right, so that gives you the 5-number summary. It tells you that it's skewed. So that's how easy it is in decimals, right? Once you've got your listing, that's the time-consuming part. But then you just type histogram or box plot, whatever, and then you'll have it, whichever graph that you want, and you can sketch accordingly. I don't think we need to do the second example. I mean, it's going to be very similar to the first. So that's pretty much it for section 8.4.